People keep asking me why I'd bother learning C in a world where Python can do almost everything in 5 lines and Rust exists. And every time I get that question, I think about the fact that the operating system you're running Python on, the kernel handling every syscall, half the tools in your security toolkit, and basically the entire history of computing security vulnerabilities, all of it traces back to C. You don't learn C because it's convenient. You learn C because it's the language the machine actually speaks. And once you understand it, every other layer makes sense in a way it never did before. Let me be honest about something first. C has a reputation for being painful, and that reputation is partly earned. No garbage collection, no safety nets, manual memory management, and the compiler will let you do genuinely insane things without complaining. But that's also exactly why it's the best language for understanding security at a fundamental level. Almost every classic vulnerability class, buffer overflows, use after free, format string bugs, integer overflows, exist because of how C handles memory. Learn C properly, and you're not just learning a language, you're learning why an enormous chunk of cybersecurity history happened the way it did. The way most people try to learn C is the same mistake people make with every language. They grind through syntax for weeks, doing exercises that print hello world variations, and quit before it gets interesting. The fix is the same fix every time. Get the fundamentals fast, then immediately build things that are actually fun. For fundamentals, learnc.org is free and genuinely well structured, and it gets you through syntax, pointers, and memory basics without wasting your time. Don't skip pointers, and don't rush them either. A pointer is just a variable holding a memory address. But the moment that idea actually clicks, that you can point directly at a location in memory and read or change what's there, C stops feeling like a programming language and starts feeling like you've been handed direct access to the machine. That feeling is the entire reason this language matters for security work. Once you've got 2 or 3 weeks of fundamentals in, here's where it gets genuinely exciting. Build a simple TCP chat client and server. This forces you into socket programming immediately, and socket programming is the foundation underneath basically every network tool you've ever used. Once you've written the code that opens a connection, sends bytes, and reads a response yourself, tools like Nmap and Netcat stop being black boxes. You know exactly what they're doing because you just built a miniature version of it. After that, build your own basic memory scanner, something that reads through a running process's memory looking for a specific value, similar conceptually to how game cheat engines or memory forensics tools work. This project alone will teach you more about how processes actually live in memory than any textbook chapter, and it sets you up perfectly to understand tools like volatility from the inside, instead of just using them as a black box. Then, in a properly isolated lab environment, write a basic buffer overflow against an intentionally vulnerable program. There are purpose-built vulnerable C programs designed exactly for this kind of practice. Watching a Stack Overflow actually overwrite a return address that you wrote and predicted yourself is one of those moments that permanently changes how you read code. You stop seeing buffer handling as boring boilerplate and start seeing it as a place where things can go very, very wrong if you're not careful, which is exactly the instinct that makes someone good at finding and understanding real vulnerabilities. For resources beyond learnc.org, Jacob Sorber on YouTube is one of the best channels for actually understanding C at a systems level, genuinely engaging and never condescending. The C programming language by Kernighan and Ritchie is the classic for a reason. It's short, dense, and written by the people who created the language, but treat it as a reference once you've got fundamentals down, not your starting point. For the security side specifically, Hacking, The Art of Exploitation by John Erickson is one of the only books that teaches C and offensive security side by side, building toward real exploitation concepts instead of teaching them as 2 separate subjects. Here's the honest timeline. 2 to 3 weeks on fundamentals, a month on the socket programming and memory scanner projects. By month 2, you're ready to actually attempt your first buffer overflow in a lab and start reading real C-based exploit code on places like exploit.db and actually following what's happening line by line instead of skimming past it. Go write some C tonight, even just the chat client. You'll understand more about how computers actually work in 1 weekend with this language than you will in months of staying purely in Python.